And we're live. Okay. Hi, everybody. Thank you for joining us. And welcome to the second episode of the OpenTelemetry Bootcamp. So we stream live on YouTube and LinkedIn and Twitch. So feel free to join each of these channels. If you're new here, so the purpose of the bootcamp is basically to go over everything OpenTelemetry from the basics all the way to the advanced concepts. And so each episode is basically gonna go a little bit deeper into the advanced concepts. So you might want to watch the first episode. You have the link in the description. Also, if you want to keep the conversation going, you can join our Slack channel. Also link in the description if you watch on YouTube. Yeah, let's begin. Michael, the stage is yours.
Cool.
Away.
Thank you. Thank you very much. So, hi, everybody. And let me start by sharing my screen because you want to see the screen and not me. Okay, so yeah, the OpenTelemetry Bootcamp, our second episode. If it's your first time, I'm Michael Aberman. I am the co-founder and CTO of Aspecto. That's not that important for you. What's important for you is that I've been working with microservices for quite some time, for about 5 years, specifically with OpenTelemetry in the past 2 years. And working with OpenTelemetry in the community led me to understand that there is kind of a gap where people are trying to get started with OpenTelemetry, and they find it hard, they find it complex, and I want to help you guys. I want to help you guys get started. I want to help you to not fall in the same pitfall I've fallen several times. So yeah, let's get started. So the previous episode was mostly around understanding how OpenTelemetry works in general, the overall architecture, the purpose of OpenTelemetry, and how it looks when you're starting to implement in your system, collecting traces, logs, metrics, all of those. Today, we're going to not talk a lot, but actually, well, I'll be talking the whole time, but I will show you a lot of code. It won't be diagram and stuff. It would be mostly code and understanding how OpenTelemetry works, and specifically the OpenTelemetry SDK. So we're going to take focus on kind of the front end, the client side, if you will, of OpenTelemetry, the side that collects data and how it's being shipped. So it is a live session. And so I'm doing live code. If something doesn't work, don't hate me. Try to learn from what could work. And try to learn how to debug, how to troubleshoot, and all the resources that I'm showing today are going to be available in a Git repository, as you can see in the link. And also, if you have question or anything of that sort, you can go to our CNCF Slack channel, OpenTelemetry Bootcamp, and ask questions there. Okay, so let's dive into today's chapter. So the first thing that we're going to do is we're kind of going to define what is the purpose of OpenTelemetry. What is the purpose, and from that purpose to conclude what the structure. Specifically, again, the OpenTelemetry SDK, the client side. Everything that we're going to talk about, we're going to implement. We're going to take the same simple demo app that we did in the previous episode and make changes, and from that learn how everything is operate, and then discuss a bit on common use cases that you should know about. Sometimes OpenTelemetry is just easy plug and play, and sometimes you need to work hard for it. So those will be the use cases that we're going to cover. Okay, so if I'm trying to define what the purpose of OpenTelemetry, I would say it had three objectives. Objective number one is to collect data about the application, to collect data about how the application performs. And that's step number one. Step number two would be to take this data and then ship it somewhere. We need to ship it to some kind of a backend to store it so we can process it, visualize it, search on it, whatever. And the last thing, we're talking about OpenTelemetry, so most likely we're talking about distributed application. And we're talking about distributed application, we need to be able to propagate the context between services. If you remember, we saw how service A communicated with B and we were able to see the whole story. So we need to propagate the context between those services. If we are doing all those three things, that is the core of OpenTelemetry. We will see more feature and more things that are going to be happening there, but those are the main things. And to do that, we can take a look at this diagram. And in this diagram, you can see we have the libraries. Those are the libraries that you're working with in your code base. This would be your HTTP library, your REST library, your database library, your Redis library. And each one of these libraries in runtime are doing some actions. So the libraries are invoking some method calls, and with that sending an API call, with that sending a database query. And instrumentation is something that attaches to a library and in some way is going to collect data in runtime what this library is doing. This could be an auto instrumentation where it's automatically working with this library. And we see there is something else called manual instrumentation that in case you want to collect data outside of a library. So that's step one, that's collecting the data. The other end of that is to export it, is to send it to a vendor, to send it to a database, to send it to some visualization tool. So that would take the data generated by the instrumentation and send it. And in between, you have a processor. A processor is kind of a data pipeline thing. It's going to get the data from instrumentation, process it, and then export it. That's all how it works for spans and traces. Very similarly, we're talking about metrics. You have a metrics provider. This is where the metrics are being aggregated, then moved to the processor, and then exported to whatever destination you may want. In the previous episode, we exported everything to Prometheus. This is the basic architecture of an OpenTelemetry SDK. We do have more components, but we would review them as we progress. So let's start by talking about instrumentation. So as I said, instrumentation is going to patch, attach, integrate into a library. And I'm talking specifically about auto instrumentation. So we're going to collect data in runtime, and it's going to produce spans. And those spans are going to represent what happened in this runtime. And those spans are going to be based on two things. Number one is going to be based on specification. When you collect instrumentation about a database, is going to have its own specific instrumentation, how it should look like, and the semantic convention is going to make sure that all the names are exactly the same. And when we're talking about that's like the raw thing that automatic instrumentation is offering, you're going to see more configuration, more things that you can do it with that. How you can find instrumentation. So there are tons of instrumentation being developed by the community. And for that, OpenTelemetry is having an OpenTelemetry registry. So when you go to the OpenTelemetry registry, this is where you can search for everything that you're looking for. So let's say that you're looking for instrumentations in Go language. So here you can see all the different instrumentation available for you. And if you click the instrumentation, you're gonna see the code itself. Most cases you would find also a good README describing how to operate it. This is automatic instrumentation. We do have manual instrumentation. This is where you are writing directly to OpenTelemetry. Now I want to create a new span, and you need to operate it. So let's take a look at our code. And in our code, just to remind you, we had the user service, and we had the user service, we have the item service, and we have the tracer. Both services are using the tracer. We have two different processes. So process number one is the user service, process number two is the item service, and both of them are using the same service, so it's easier for us to work with. And looking at our code, we have some function called register instrumentation. And you can see here that I have chosen to use only two instrumentation. The express instrumentation, it's a RESTful service, a RESTful server, and the HTTP instrumentation that, the HTTP module responsible on incoming messages and outgoing. And when I am adding a new instrumentation, that's all I need to do. So for instance, if I wanted to add a new instrumentation, I would go to the registry and I would change to specifically JavaScript. Let's change it to JavaScript. And now I can add any one of those. So you can see the list is quite long. So whatever thing you need to add, you can add right here. And each instrumentation has its own set of configuration. So you could configure it to work the way that you want it to work. For instance, we have the request hook. The request hook is a function. The function gets a span and gets a span. That's the current active span. And also it gets some information about the request. So it would be request info. So now that I have this function, I have access to my request and I have access to my span. So I'll go to my span and I would set a new attribute. Let's say I want to record my request headers. So request headers, that would be the key. Then I go to request info. And in request info, I have access to the actual request and then headers. And this should be a string. So let me stringify it. And we are good to go. So what I did here is I basically took from Express, I added the hook to get the active span and the current request, and I added more data to my span. So if I'll invoke the API call, and I'll go back to my user service, and I'll look for an HTTP, an Express span, you could see right here that now I have the request headers. So this is how you are able to manipulate instrumentation in order for you to get the data that you're looking for. This is super important because anytime that you're going to miss something, you first want to go to the instrumentation responsible for that and see if there is already a solution. Okay, with that being said, sometimes we need to do stuff manually, and there is no escaping from that. So let me give you an example where you might want to use menu instrumentation. So let's say in my user service, I'm going to set up a timer. So let's do set interval. And in our set interval, I'm going to have a function that is going to, let's say, send an API call. And it's going to do that every 1 second. So let me grab an API call right here so we will make our life a bit easier. So now every second, we are sending an API call from our user service. Let's say that the purpose of this API call is to refresh the cache. Cool. So if I'll go to my user service and search, you can see here that I have an HTTPS GET. And if you're a developer that doesn't know how this service operates, it would be kind of hard for you to understand what is this API call? Why do I need it? And we can make it far more understandable for the developer. So I can go and give it like a name. So I'm going to create an additional span. So I'll go and I'll grab the current trace, and not the tracer, which we will understand in a second what it is. And I have here two functions, start span and start active span. Let's start to work with those a bit and try to figure out what's happening. So I want to have a span with a meaningful name. Let's say refresh cache. So the next developer is going to understand what it is and how it works. So I have a new span. So if you have a start span function, you're probably gonna have span.end. So, and if I'll ask you if you see any problem with this code, I guess, unless you're familiar already with how OpenTelemetry works, that you say that this code looks fine. New span, do your thing, and the span. All good, right? Going back to Jaeger, you're going to see something really annoying. So we have a trace with one span called refresh cache, and we have a span that is the HTTP call. And the reason that that's happening is that we need to run this operation in the context of the span. To do that, we have the function active span, start active span. And this one is working a bit differently. You can still provide the name, then you get a callback with access to the span, and you can run whatever you want within that span. And because it's JavaScript, we need to put here async. And now the end span should be within that function, and we don't need that. So basically, the operation is async, and we're saying anything that happened inside this callback would be under the context of start active span. Now let's go back to Jaeger and make sure everything works as expected. Okay, so now we have refresh cache every 1 second. And when we are clicking on it, we can see that we have refresh cache and then the HTTP call. Now, if I'm a developer and I'm looking at this UI, it makes far more sense for me to really understand that what is the meaning of this span. Now let's put it every minute, so our Jaeger won't be overflowing with stuff, and it would make our life a bit harder when we have more and more stuff in our application code, in our demo code. So you have automatic instrumentations where you get everything working out of the box. You can configure it, and you can search for more instrumentation in the registry, and you have a manual instrumentation. And for that, you basically change the application layer code. You need to write a dedicated code. Your business logic is somewhat working with OpenTelemetry, and then everything is your responsibility, and you need to understand how things are working. You need to start a span, you need to end a span. In case of an error, you need to set the set to call set status and indicate that it's not working, that it was failure. And you can add attributes, events, record exception, but it's all your responsibility. The sky is the limit, but you need to know what you're doing. And the common use cases to human instrumentation is, as we did right now, use internal activities such as timer. If you want to add additional data that is not present, and in case that simply don't have auto instrumentation supported. So for instance, I think a Cassandra database doesn't have instrumentation in Node.js. In that case, you may need to do it by yourself, either with manual instrumentation or contribute your own auto instrumentation, and we will talk about it in episode 5, how we're actually doing it. So this is about instrumentations. So now we are able to produce spans, and those spans eventually need to go to the exporter in order to be shipped somewhere. And in the middle, we have the processor. The processor gives us the ability to detach instrumentation and exporters because they're two unrelated things. So the processor responsibility is to receive the span. It gives you a chance to observe the data, change it, delete it, um, add more things to it, in for sampling rules that we will see a bit later. And basically takes the data from the instrumentation and pass it down to the exporter. So let's look at our code. In our code, we already have a processor. So you can see that right here, we have a simple span processor. That's, well, as it sounds, it's a simple processing span. It's simply processing the spans. And any processor needs to get the exporter. So this is how we are connecting between the two. And we choose to use Jaeger exporter. The simple span processor, what it's doing is very, very simple. Basically, it gets it gets a span and it ships it to the Jaeger. And for instance, we can put that aside and change it to use batch span processor. What batch span processor would do is would actually buffer it. So for instance, after providing the, the exporter, we can provide some configuration, such as timeouts, max batch size, max queue size, and a delay. So for instance, if you want to wait like, I don't know, let's say 7 seconds before shipping something out, that would allow you to do mostly performance improvements and that kind of things. Let me try and show you that it's actually doing batches, because it would be cool. It would mean that we need to tweak a bit the OpenTelemetry and how it works. So we are talking about the internals of OpenTelemetry. So let's try to find that. We are looking at processors, and we are searching for the batch processor span base. Okay, so this is how the processor actually looks like. That's the processor code. And you can see here that we have a function called add to buffer. So in our add to buffer function, what I'm going to do, I'm going to say buffer size. So we'll be able to actually see the size of the buffer. And we need to print the length of this array. Cool. And I do want also to print once it's flushing. So let's write flushing. Okay, and now what I would like to do, I'll go back to my user service, and we did a span every 1 minute. Let's reduce it back to every 1 second. So we are adding spans every 1 second. However, we are processing it and sending it to exporter every 7 or 8 seconds, however I define it. So when we refresh it, you can see that the buffer size increases, and then it would flush it sometimes. Oh, yeah, flushing. Okay, so this is giving us the showing us how it really works in terms of buffering. Okay, so in terms of processors, usually you don't need to do much with processors. Usually you would use the predefined ones. You don't have much interaction with them. I would use batching just in sake of performance. OpenTelemetry has its own impact by itself, so optimizing for performance, that would be great. Okay, great. Moving on. So in span processors, we have the simple, we have the batch. We know what those are doing. No hop span processor means that processor, the spans won't be processed, they won't be shipped to any exporter, and multiple processor allows you to set up multiple. And spans processors are dedicated, of course, for spans, and you have metric processors as well, specifically for metrics. Now, when we're talking about exporters, the responsibility of exporter is to send it somewhere, as well as things like authentication, like adding metadata. So if you look at our Jaeger exporter, you could look here and look at the whole list of what you can do with the Jaeger exporter. For instance, specifying a different to set up a password and username for authentication. And now that you're already expert with OpenTelemetry, so you can decide that you're going to have two exporters. So let's do console exporter. Let's do new console span exporter. And that means that on every span that we're creating, it's not only be sent to Jaeger, it would also be written to your console, which is very good for debugging purposes. So this is for the use case where you are actually using, you want to use multiple exporters. This is how you get it done. In terms of exporters, there is a lot of them. The predefined one are exporting to Jaeger and Zipkin. Zipkin is another open source solution to have a UI for traces and also to ship to the collector, which we'll discuss in the next episode. And the in-memory one, if you want to keep them in memory, the console to write them to the console, no hop to send them nowhere. And OTLP is an exporter that knows how to send metrics and spans all together. For the metrics in our application, we chose to use the Prometheus exporter because we want them to be sent to Prometheus, of course. Okay, just about a word about protocols. So you can set it either as a HTTP or gRPC or in JSON format or protobuf, up to you. Okay, so till now, what we were doing, we were sending the data from instrumentation through the processor via the exporter. And we had all the data that we sent was specific to the activity that we were calling. So we added the HTTP headers to a specific HTTP call. But what happens when you want to send more data? That you want to send data that is not specific to activity, but rather specific to the environment, to the process you live in. If you're running in cloud, maybe you want to know in which region you're running. So all of those things are metadata that you want to be sent out with any span. And we're actually already using it. So if you take a look at our code, so we have here the resources, and one of the resources that we are using is a service name. So we can add our own resource. So let's say my resource, and let's say the value is 1. And now if I'll invoke an API call and go back to Jaeger, and let's go to the user service, find traces, find a trace. So any trace that you would open, you would be able to see the resource number 1. And this is giving me metadata about the whole application, the whole execution. So you can add whatever you're looking for. I also wrote something about detectors. So detectors is a predefined class that is going to collect data for you. So for instance, you could see that we are having here a service sync detector, and the service sync detector, it's going to detect stuff about my service resources. Service resources. That's cool. So actually, I won't be needing this one because this one will be automatically collected for me. So I can remove that. And now I can take this statement and let's put it outside of the resources. I deleted one too many. And let's call it custom resources. Cool. So now I have two different resources, and all I need to do is to do service resources and merge it with the custom resources. And I have too many S there. And now I can work with predefined ones. Those are very, very useful when you're trying to do something that somebody did before you. For instance, if you want to know if you're running within AWS or not. So AWS has their own API that you can communicate with, and they're going to tell you, yeah, you're running in this region, in this availability zone, this is your IP, all of those things that may be interesting for you. So those are predefined that you can use and just make your life a bit easier. Cool. So and so those would be how you're basically sending metadata with your spans, whether that's manual and custom for your needs, or whether they are predefined by somebody else. We actually created a few detectors. One of them, which I really like, is the Git detector. So the Git detector, if you for some reason have the Git information running in your process, the .git file, then it's going to, on every span, write the commit ID, the commit hash that you use. And this is going to give you a good relation between what version created this span. And you may ask yourself, why would I have the .git folder? So in many cases, unless you remove it, like in Docker situation, unless you specify not to take it, by default, it's going to be there. So if it's there, you're going to have those resources. If not, it's not going to be there. So you can definitely check it out if you find it interesting. Okay, so before moving to the new sampler thing, so we are collecting data, whether it's from a specific activity or from resources that we collected, and now we're starting to ship data to the exporter. You may want to sample the amount of data that's being sent out from various reasons. Either this is data that you don't want to send out, like in the previous episode, somebody asked me, uh, there is an API that I don't want to send out. You can use a sampler. You can say, if the span that I'm currently observing is to a specific route, let's omit it, let's not record it. But also you can use it in order to say, okay, I don't want to have 100% of my API called being instrumented. I want to take only 50%, only 20%. So then you can use the sampler in order to detect that, in order to basically allow what's being recorded or not what. So basically, it's going to do, it has two responsibility. Responsibility number one is to decide whether to sample or not, whether to record or not. But another very interesting responsibility is whether to respect or not upstream services decisions. And what do I mean by that? So you are currently a sampler running in service B, and service B is getting API calls from service A. When service A is going to sample it, it may decide that it's not going to record this specific span. So if service A won't send a message to service B saying, hey, please don't collect that, service B might collect it. So actually, even when services are not decided not to sample, they do inject headers into the HTTP call or whatever other type of communication it may be in order to tell the next service in line, hey, I decided that you shouldn't sample it. Please don't sample it. And then we can decide whether we're expecting it or not. And this is something that we'll dive into with far more details in episode number 4. This is where we are going to make sure that when we are sending high volumes of data, that we can work at that workload. So you have 4 predefined samplers. So basically, when you are creating the tracer provider, which we'll discuss a bit more details later, you can decide what the sampler may look like. So you can say, for instance, always off sampler. So this means no sampling done whatsoever. You can also do always on sampler. All of them would be sampled. And you can do a few other things. So you can do first new parent-based sampler. This is a sampler that is going to respect what my previous service decided to do. And then you need to say, okay, I'm respecting what my previous service decided to do, but in case that I am going to sample, what should I do? How do I take a decision? And this could be always off, always on, and this also could be new trace ID ratio-based sampler. And here you're providing a ratio. So if I'll provide it anything between 0 and 1, that would be the ratio of how much to sample, in this case, 50%. So this is how you can decide how much sampling you want to get done. A sampler is a critical thing for you to have. It's something that if you are going to run OpenTelemetry in production, you are going to play with, and you are going to have a good understanding how it works, because it could be a bit more complex. Again, more info about in episode number 4. Okay, we are moving on. So now we have the ability to collect data, export it, attach metadata, control how much data we're actually sending out of the OpenTelemetry SDK. And now we are talking about provider. And the provider is actually kind of a wrapper thing. We just worked with the provider. So the provider allows you to kind of decide all kind of things that are related to the behavior of how traces are being generated, how to add some resources, how to behave when it comes to sampling, how to generate IDs of a trace ID if you want something unique, how to determine maybe you want to have some span limit. All of those things are all wrapped together in this wrapper called provider. Okay, so looking at what we accomplished so far, we are able to collect data, add metadata, sample it, and ship it. The only thing that we haven't talked so far is about how to propagate the context between those services. So basically, in the first session, we discussed that OpenTelemetry is able on our behalf to inject headers into the HTTP calls or any type of other communication calls. So those headers are going to represent how the data, who sent the data, and who received it. So if we're looking at how that's done, we can talk about the context propagation. And the context propagation, and here I'm discussing specifically the trace context, is responsible on 2 things. Number 1 is to inject the context into outgoing activities. and the other side, when I'm receiving an API call, how to extract the context on incoming activities. The default trace context is official by the W3C, so you can go and read all about it. You can read about the trace parent header, which I'll discuss in a second, and the trace state headers. Those are the two headers that are going to be injected. The trace parent, which is mandatory, you're always going to have that. It's going to have three things on every interaction between services: the version, the trace ID, the parent span who invoked this action, and a flag about this trace telling whether it's sampled or not, or mainly talking about sampling. Again, as a sampler, I need to know if my parent decided to sample or not this trace, so I need to know. So trace parent will give you the context of the trace ID, who is your parent span ID, and whether it should sample or not. The trace state, that's something you may encounter. Probably not something you're going to use because it's for vendor specific, that is giving the vendors the ability to put some information about traces. Okay, so I do want to show you an example of how this thing could look like. So in many scenarios, when you would work with OpenTelemetry, you would work in a distributed system. And when you would work with distributed system, you may want to use with some pub/sub, with some queue, with a messaging system. Most messaging systems allow you to inject headers or metadata or attribute into messages. So in SQS, the AWS queue, you have attributes. In Kafka, you have headers. And then you could do an onto instrumentation, because the instrumentation itself, once it sends a message, it can inject the headers. And when it consumes the message, it can extract the messages, the headers. However, some of those does not support it. Some of those do not allow you to have headers. And this is a problem. This is a problem that you are going to have to solve. You as a developer, as a consumer of OpenTelemetry, you would have to solve it yourself, because an auto instrumentation won't be able to solve it for you. So I want you to introduce you to one of these use cases, and I'm specifically referring to a scenario where we are having a pub/sub message. And here we are using Redis, and specifically Redis. And as you can see, when you're looking at the messages that you can send and you can publish, you only get two things. You get the channel name, the message name, and also a third one, if you want to, a callback determining if it was successful or not. So this is all you get. You don't have a room, you don't have a parameter for sending a metadata. That means that if I'll call the /pub, let's see what happened. So let's go to our client. Let's do /pub. We got an OK. Everybody's happy. And if I'll go to our item service and search for the /pub, if I'll be able to do that, because it may not work. You see, I told you when you do live coding, stuff sometimes doesn't work. Okay, let's try to fix it. So it received the message. We got an OK. Overall, looks fine. Oh, I will tell you why it's not working, because I didn't have an instrumentation for Redis. That's important. So let's do new Redis instrumentation. Hopefully, IO Redis instrumentation. Okay, IO Redis instrumentation. Cool. I'm not going to provide any configuration. And now we have exposure that's working. I am going to remove this one. And I think something may not work with the resources for some reason, but let's see if I'm able to make it work. Let's see. Still not working. Why is that? I'm not sure. Oh, I think, okay. So I changed the name of the service, and I want to go back because for some reason it's not working. So I have an idea why it's not working. I'll show you why it's not working. So the reason it's not working is that the detector is by default taking the name out from the package JSON. And I'm using the same folder for both services. So I got the same name for both services and not the name I provided right here where I initiated the the tracer. So that is the reason why it doesn't work. So let me fix that real quick. So I'll take the semantic conversion attribute and I'll choose the service name and I'll provide the service name. Okay, now I really hope it is going to work. Refreshing /pub, find, and you can see that it's still not working. We are not going to let it go. It is going to work. Okay, we finally made it work. So we got to Jaeger our data, and you can see we got the API call to /pub as expected, and you can see that we have publish. And in this publish, we have the channel name as expected, which is my channel. Let's look at the code. My channel, this is my message, and we have all the data. However, we can't see the subscribe. We can't see how data was consumed. If we would go to our user service and we would look and try to find exactly the HTTP call. I think I have some issues with Jaeger because it's like not refreshing really well. So anyhow, I'm not able to see how data was received in my user service. So we are doing a subscribe, but we are not able to get this data, to get them connected to basically what I want to see. I want to be able to see from my user service when I am looking at the /pub message. I want to be able to see the whole thing. I want to see the pubs, I want to see the publish, and I want to see the consume. To get this done, I need to work a bit harder. So what I need to do is I need to inject into the message that I'm sending, I need to inject the context propagation. So let's do that. So I have prepared the code right here, and let's review this code. So looking at our code, when we're getting /pub, I'm getting the active span, which would be the express incoming call. I have the payload that I want to send, and now I'm telling API, that's the OpenTelemetry API, go to the propagation that we have selected, again by default, the W3C, and please inject to the payload the active span. That would inject the trace ID, the span ID, the trace flag, as we said. And I am writing the payload in my publish, so we will be able to see it in our UI. So in Jaeger. So let's go back. Let's search again. Okay, and now you can see that in my DB statement, I used to have only message, but now I have both message and the trace parent encoded. So basically the trace ID, again, encoded, but not that encoded, but the trace ID, the span ID, and whether it's sampled or not, which it is because we can see it. Okay, so that's the inject part. That's how, when I'm publishing a message, how I am injecting the context. In my user service, I need to extract this, to extract the payload, to extract from the payload the context. So let's do the following. Once I'm receiving a message on message, I would like to do the following. First of all, I'm getting the message as a string, and I want it to be an object. So we are deserializing it to be an object. Then I'm extracting, using the same propagation from the payload. Please give me the propagated context. And now start a new span. And when you're starting a new span, call it consume a message, provide the attributes of the message itself, and also use it and create it under the propagated context. That should result in a one big trace that includes both the produce and the consume or subscribe of Redis. And again, eventually close the span. Okay, so now let's see if everything works. I really hope it does. I do want to do something that would do cache busting. So now, if I'll find a trace, you can see that when I'm looking at the trace, I can see that I have 3 spans from item service as I used to have before, but now I also have a span from user service, overall 4 spans. And you can see here that I have publish and I have consume message, and I have all of them all together connected. This is a great example where you really need to get to know OpenTelemetry and to understand how it works, because not everything is going to be plug and play, magically works out of the box. Okay, so this is about the trace context. You usually don't need to change it unless you have a good reason to, but you sometimes will need to know how to work with it. When you're sending context propagation, it doesn't have to be for the use case of connecting spans one another. You can also use it to send data. So for instance, if service A did some random decision like A/B test, and you want to make sure service B is aware of that, so there is something called baggage in OpenTelemetry that you can use. And this is a really good use case when you're passing business-oriented data between services. You want to know what was the upstream services, or maybe you want to understand the upstream decision that was made. So that's the solution for you. So we took the 3 things that OpenTelemetry is responsible on: collecting the data, propagating the context between services, and shipping somewhere. All of those, we did those, and we took the parts of OpenTelemetry, broke it down, and understood how OpenTelemetry get those things done. So this is like a good understanding of how OpenTelemetry works and what's the motivation of each component. The overall solution looks like that. And this is something that if you haven't known so far, you can understand now better how it's working. And the idea for me is that if you need to open OpenTelemetry and to make a change, that you will have a good understanding which component you need to go through. You don't need to to remember everything, but it will. You know that if you need to attach metadata, you would go to resources, for instance. We always talk about the OpenTelemetry SDK. The OpenTelemetry SDK, it's not the only thing that you would see if you go through OpenTelemetry repositories. You would also find the OpenTelemetry API. The API is a layer that exposes the SDK, and you have 2 two or three reasons why you should work directly with the API, and in some cases you saw we work with the API. So the SDK is the actual implementation. The API is the API that is exposed to the outside world. If you have too much free time, you can decide to write your own OpenTelemetry SDK, but that's not the reason it's out there. The reason is that in cases, for instance, if you're managing some infrastructure library or some open source library, and in case somebody is having OpenTelemetry and you want to add data, so you wrote some open source that is a MongoDB plugin. So you want to add data to OpenTelemetry, then you only need to use the API. You don't need the actual implementation. So don't try to rewrite the OpenTelemetry SDK. That's like really, really hardcore coding. We talked a lot about tracing. We haven't talked much about metrics, and we almost never mentioned logs at all. And that is because this is the status of OpenTelemetry. So you could see here the tracing, the SDK, the API, and the collector. So the SDK and the API are stable. The collector is still experimental. Metrics is almost all experimental, and logs is basically in a draft, kind of saying tracing is stable, metrics in beta, logs is in alpha. And this is why we are focusing mostly in tracing, because that's the most content we currently have in OpenTelemetry. If you want to follow the OpenTelemetry progression, you can go to opentelemetry.io/status, and you'll have everything that you're looking for there. A word maybe about logs. So what people are doing is they're instrumenting the logs library, and basically every time you write a log statement, it automatically would inject the current trace ID to the log, making it easy to correlate between logs and traces. So if you're looking for a log solution, that may be the solution that you're looking for. So that was my almost hour speech about OpenTelemetry. If you have any questions, feel free to write them on the chat in our Slack channel. Thank you very much. And we do have a bunch of resources that are very much related to what we spoke about today, comparing what is faster, protobuf or JSON, and reviewing all kind of how to implement OpenTelemetry in Redis PubSub, or how to choose in general which messaging system you should look. So all of those are available for you. And next time, we're going to talk about mostly about the backend stuff rather than the front-end stuff as we worked on today. So mostly collector, deploying it, and starting to think about production, because that's the next thing that we are headed. And thank you very much.
Thank you so much, Michael, and thank you everyone for joining. So this episode will be on demand on our YouTube channel. And yeah, next week we have another episode 3, Wednesday at 10 a.m. PDT. So make sure to join, and have a great day.
Thank you. Bye-bye.
Bye-bye.